Well, good morning, everyone. I'm Jacquelline Fuller, and I'm the president of Google.org, which is Google's philanthropy. And I am so pleased, so pleased to be here today with our friends. This is Gavin McCormick from O'19, Malou from Médecins Sans Frontières, also known as Doctors Without Borders, and Anandan from Wadhwani AI. So I'm going to provide a little bit of context on Google.org itself and the AI Impact Challenge, and then we're going to hear from some of our winners about the important work that they are doing globally. So Google.org is Google's philanthropy, and our mission is to help bring together technologists such as all of you and experts on the front lines who are dedicated to improving the environment, education, poverty, to really solve complex challenges and apply resources, expertise, communications, and reach together to help us really take a step change forward. For anyone who was in Mustafa's talk right before this one, he talked about how applying machine learning can help us take a step change, even when all we're doing is changing VML models and not even any changing to the underlying data and infrastructure. So as Google.org, we like to think about how can we help Google itself with our own technologies that we're applying, such as the flood forecasting you might have heard about in the keynote. Well, we have a winner from the AI Impact Challenge who's applying those kinds of techniques for landslides. So the AI Impact Challenge itself was global in nature. We provided $25 million in a pool and opened it to the world and said, how would you use artificial intelligence, machine learning, to make a huge difference in improving the world in your specific area? And then the winners receive the funding, the resources, but also expertise. They all get assigned help from Googlers from our research group. They have access to an accelerator called Credits. So basically, it's a partnership, an extended partnership, to see how Google can help them carry out their vision. And what was so exciting is when we first did this competition, it came out of a conversation actually with Sundar Pichai, our CEO, who said, he is so excited to see how AI can be applied not only at companies like Google, but for the frontline heroes who are really trying to change the world when it comes to global health and environmental concerns. How can we apply AI in those settings as well? So out of that conversation, we launched the Impact Challenge, not really sure exactly how it would turn out. We partnered with Jeff Dean, the Google research team, and the effort's being led by Bridget and Molly, who are here and can talk to you afterwards if you're interested. And so we put it out there in the world, and we had more than 2,600 high-quality applications from more than 119 countries. And from those, we distilled it down to 20 winners. And we have 3 of them here today. So the conversation is really going to be to understand what you all are doing, to hear about your inspiring stories. And I think we probably have some technologists in the room who are really interested in thinking about how can they apply technology to their issues areas, the causes that they care about most. So maybe you'll have some advice and inspiring words for the audience as well. But why don't we start by each of you just sharing your name, a little bit of your bio, and then tell us a little bit about the problem that your organization is trying to solve. And Gavin, should we start with you?
Sure. So I'm Gavin McCormick, co-founder and executive director at O'19. I am not a developer by training. I'm an economist. So what am I doing here? I had worked formerly at U.S. Department of Energy and then was a PhD student at UC Berkeley when a new form of statistics was coming out in economics, the so-called credibility revolution. And it's being applied to environmental problems to solve problems that were previously considered impossible. So one of those is, where is this energy coming from? We used to think you couldn't know. Turns out, with new algorithms, we can flip a light switch and say, what power plant precisely will provide a little bit more electricity if you plug in a phone or use an electric vehicle or use some energy? And the only reason that's interesting is it turns out it changes incredibly fast. So if you wait 5 minutes, that could be the difference between getting energy from a coal plant or getting energy from a solar panel. And so there's actually this like entirely new dimension in environmentalism that data just opened up. Instead of just using less energy and helping the environment, let's use it at very specific times. So my organization, Wattime, was founded at a hackathon where we figured out there's about 20 billion IoT devices worldwide that can actually have some code that is very flexible on exactly when they use energy. So we produce an API that says watt time is the best moment to use energy if you want to have less environmental impact. Doesn't make any money, but it's a really significant source of emissions reduction for climate change and air pollution worldwide. One of the interesting things about it is it was only possible because the US federal government has this like amazing open training data set on all the pollution from all the power plants in America. Basically, no other country has that. And so Wattime realized that if we wanted to provide emissions reductions in other countries, if we wanted to make this a global technology, we needed some way to know what's going on at every power plant in the world. So for this project, what we are going to do is use visual recognition software and machine learning on imagery taken by satellites of all the power plants in the world. And it turns out if you use the right types of data, such as infrared imagery, you can actually detect how much pollution is coming out of every single power plant worldwide based on a satellite infrastructure. So first of all, that was kind of fun, but then the other piece of the puzzle is we quickly discovered that a lot of other environmental NGOs want the same data. So I'm here representing Wattime, but we're actually partnering with a lot of the biggest environmental NGOs in the world, decided to collectively pool our resources and go on in this project together. So I think it's fun that Carbon Tracker will be using this to figure out what are all the cases where actually it would be cheaper to use renewable energy than fossil fuels? Can we just shut down a lot of the world's coal plants? World Resources Institute will be using this to see, are any countries polluting more than they legally are bound to under the Paris Treaty? There's a whole bunch of different environmental applications for the same project.
Great. Thanks, Gavin. Nada?
Thank you. So I'm Dr. Anandan Malou. I'm a PhD in microbiology. And so after my PhD, I decided to work with Doctors Without Borders, or Médecins Sans Frontières in French. So we are an international medical humanitarian organization providing care for population in need because of war context, because of outbreaks like Ebola, cholera, or for population who are excluded from the healthcare system. So we work in more than 70 countries. And my work for Médecins Sans Frontières, or Doctors Without Borders, as a microbiologist, is to identify diagnostic tools that can help to diagnose infection in the patients that we receive in our different projects. So I worked in Uganda and Mali in Africa, where I was mainly specialized in working on pediatric population, so children arriving with malnutrition and having also an infection with the bacteria. And then I worked in Middle East with war-wounded patients. So those patients were also arriving in our facility with infection, and it was very important to diagnose this infection in order to avoid amputation or medical complication. So the challenge in identifying diagnostic tools for low and middle income countries is that most of the diagnostic tools that we have are not adapted to the constraint of the field. Here in US or even in Europe, if you are sick, you have fever, you can go to the hospital, they take your blood, they do a test, and they will tell you which bacteria is causing the infection and what is the most effective drug to use to treat this infection. Those tests are not available in the context where we work. So the question was why they are not available. So there are many reasons. So there are problem of access, but there's also the fact that they are not adapted. So one of the reasons is the limitation in terms of human resources and trained human resources. So the idea for us was to try to find a solution in order to make the interpretation and the use of those tests easier and available for the majority of those patients that we are seeing. And I think you all heard about this problem of antimicrobial resistance. We know that for the coming decades, it is going to be one of the major public health threats. We estimate that in 2050, 10 million patients the death of 10 million patients will be attributable to antimicrobial resistance, and it's going to be mainly in the Asian and African continent. So it's very urgent for us to give access to those diagnostic tools in order to target the bacteria and to target the effective treatment for the patients in a timely manner.
Thanks. Great. Anandan?
Thank you. Yeah, my name is Anandan. Let me start with a little bit of a personal story because it's very relevant. I tell my friends and colleagues I've been doing AI as long as most of them have been alive, and in many cases more. I started my PhD in 1981, went to UMass Amherst in computer vision, had a good thriving research and publishing career. I was the head of computer vision in Microsoft Research in Redmond for a number of years. But in 2004, I felt like I wanted to do something more, and saw the opportunity to build technology for social development or social good as a potential agenda from a research side. And so convinced Microsoft to set up a research lab in India, and I went and set up that lab and ran it. Although it does much more than technology for social good, it did become known for that work. And in fact, we spun out a couple of NGOs. 9 years of that came back, and then in 2017, I met two philanthropic donors, Dr. Wadhwani, who lives in California, and his brother Sunil Wadhwani, both of Indian origin, but done well in the tech industry, well-known philanthropists, and were looking to see how they can apply their ideas and money towards social good. So they got the idea of actually setting up a research institute that would build AI solutions for a variety of social domain problems and then get it implemented. And they tapped me to be CEO. So here I thought, here's my second chance to change the world. So I quit my job, what I was doing at that time, and went back to India to set it up. We started, it took us a while to launch. We started last year in February, the Wadhwani Institute for Artificial Intelligence in Bombay, Mumbai. And because of the importance of the agenda and how hot AI is, the Prime Minister of India came and inaugurated our institute. Our charter is really simple. We want to identify societal domain problems specifically to help the underserved communities. There are roughly 3 or 4 billion people in the world who don't benefit from the kind of AI that we all do on an everyday basis. They don't take Uber, they don't do search, all that kind of stuff, and it doesn't affect their lives. And many of them, in fact, most of them, are typically wards of the government. In fact, their lives depend a lot on government programs. These are poor farmers trying to do agriculture at a very basic level, smallhold farmers, like 1 acre of land or something. Basic healthcare, there are 900 million people in India who depend on the public healthcare system, which has about 30,000 doctors. And this is true of a lot of the developing world. Basic level of education, literacy is still a problem, but beyond that, financial inclusion, getting credit if you're a poor person is next to impossible, and basic infrastructures, clean water, utilities, and stuff like that, and done in an efficient manner. So we saw the opportunity that AI, in fact, is a technology that can learn the particular conditions locally and be able to develop solutions to address them. Because these problems vary a lot from place to place, and you can't do one-shoe-fits-all type of approach. So we took that up. We are a bit more than a year old now, having a great time, couple of projects in health and one agriculture. The agriculture one is the one that's funded by the Google AI Impact Challenge. Really exciting. I have a team of about 25, 30 people now growing. My vice president for products and programs, Raghu, is in the front row. You can talk to him later as well. Thank you. Yeah.
So when we started this program, the AI Impact Challenge, it was because we thought, AI can help bring new technology to old challenges. And that it's really important to bring the experts who know the issue best, the people who are closest to the problem, together with not only the tools, but also expertise from Google and others. So what was the moment, or was there a specific moment where the light kind of went on and you thought, you know what, AI might be able to solve this in a way that it hasn't before?
Yeah. I remember that moment, and as a medical person, I was not having a solution. I was having an idea, but no solution to this need. So I spent a few years to implementing those microbiology laboratories and training a lot of lab technicians. And what I noticed is that training them to do the test was very easy, and they were very good. But then how to interpret the test and how to use it was much more difficult and takes a lot of time. That's why in Europe or in US, we have clinical microbiologists who study for years to have this expertise. And the moment where I thought, okay, this is not sustainable, we need to find a solution, was in Yemen, where we opened a microbiology lab because there was a medical need. The patients were arriving infected, and it was important for us to treat them. So we opened that lab, and I was not able to find expertise locally, and I was neither able to send expert microbiologists because it was a difficult security context. And so they were sending me the results by email, and I was checking each result and validating each result. And I thought, this is not
doesn't
possible.
scale.
No, this is not sustainable. And it was a crazy idea. And by coincidence, one day I spoke with one of my PhD friends, and so he tried to convince me to use very complicated technology. And I said, no, the solution is easy. I want something very simple. I want to take my phone, to take a picture of the test, and to have the results and the interpretation. And he called me 3 months later, and he is bioinformatician, so he called me 3 months later, and he said, we can do it. We can do it. And for me, it was like, okay, maybe, if you want. And 1.5 years after, here we are with a prototype and with something that can be really a game changer.
Yeah.
So,
Anandan, did you have a moment like that?
Last summer, after we started looking out for what problems we want to work on. Because of the initial visibility, we got a lot of people who were interested in talking to us. However, when we started learning about how to go about it, what we realized was fundamentally there are 3 questions that we have to answer. What should we work on? How do we go about building it in order so that it will be effective? And how do we get it deployed and eventually scaled? And to this, what we realized was, see, in commercial domain, there is a market. Companies like Google or other companies know how to develop the market. In social domain, well, there is a problem, of course, the capacity to pay is not there among the people that you're trying to help. But even if we find a model to do that, the market is extremely fragmented. What the approach to getting to your audience in one state, one city, one village, one region of one part of the world is very different from another. Because every place you go, there's some kind of a program that is a government program or other NGO program that exists, and you have to work through them. In fact, they exist simply because no one else is taking care of them. So what we learned is that in order to answer those questions, we have to partner with the organizations that are capable of execution and delivery. So we consulted with them a lot. So they became the source of problems for us, identifying where to work on. But equally then, they are also the people who can co-create, because if they are willing to put in their energy and interest in working with us, the solution we produce will be the right one for them to use. And one of the other things we learned in this process is the primary users of our technology are not the end users, not the farmer, not the poor mother in a village who is pregnant, but in fact, frontline workers, health workers, frontline agriculture extension workers, who are the advice givers, because they are capable of using the technology and they are part of a system of care. So we needed to learn from the partners to build solutions for that kind of a use scenario. And finally, we have to work with government in order to scale, because all these solutions, only the governments have the capacity to scale at a national or international level. And you know how challenging that can be as governments come and go, bureaucrats change and everything. But what we learned is that there is actually an experienced group of NGOs and other partners and donor organizations like the Gates Foundation and so on, who know how to do this. So they became our teachers on how we go about doing this.
So it's early days with AI, especially applied AI on some of these kinds of challenges. So as you think about your road ahead, what are some of the biggest risks or challenges that you see popping up in front of you? Sure.
I think for us, privacy and security is a surprisingly big deal. So this is supposed to be a massively collaborative open data project. But we're talking about a literal global panopticon that can see critical energy infrastructure in every country, and that would be really, really easy to abuse. So for us, the challenge of how do you make data as open as possible to collaborators while simultaneously making sure that it can't be used either for security risks, or there are fossil fuel companies that would love, instead of decreasing emissions, to increase oil consumption. How do we make a system that's as open as possible without enabling abuse? And so we're currently working on unusual contract structures and unusual data structures that we would consider semi-open source.
Mm-hmm. Yeah. Risks, challenges you see?
There are actually, to me, 3 levels of challenges. The simplest one is the AI itself. I think that's actually the one that we know how to do and can be done. The medium one is data. In social domain, data is not around, and data collection is not very easy. In fact, whatever data that exists is bad, meaning that it's not good quality. It's often false, meaning people make up stories, and it's sparse. It's not, all the information is not available everywhere, and historic data is not usually available. It's in silos and not one centralized space. So every aspect of data challenge exists. But that said, it can actually be met. You can actually create a system of data creation and work through that. The biggest challenge is actually the execution, because the kind of organizations that you have to work with are actually limited in funding and limited in capacity, and they work in short-handed really, and a diverse range of them. And potentially for us, the risk factor always is the program risk. So unless we believe that there exist current programs, like for instance, in our cotton farming work, there is an agriculture extension system for pest counting and pest management, which we can improve or replace through AI that will actually solve the problem. So then we'll feed into the system, and the only way to do that is to look for places where there is a system approach that you can leverage and so on. So that's the biggest challenge.
I think we are sharing all the same challenges, at least for the two first one. So for us, yes, the AI part is one of the challenge. The quality and the data is also one of the challenge, because we want to identify resistance in bacteria. So we need to cover the maximum of pattern of resistance, which means that we need to have access to a huge library of resistance pictures, and we need to be always updated, because if bacteria decide to mutate tomorrow and to appear resistant in a new way, we need to have the possibility to cover this. And finally, for me, for diagnostic and in medical care in general, I think there is this debate about be careful, AI is going to replace doctors, nurses, and lab technicians. I think it's very important to say that it facilitates, but it will never replace a clinician or a lab technician or microbiologist. This is just going to help us to gain also some time in order to train and to build the capacity of our human resources in the field, because the problem is today, and we need to find a solution for today. So in terms of, I think, communication and the way that we present the tool, we should be very careful that the medical professional understand that they are not going to be replaced.
Let's talk a moment about the power of partnership. So I think we're all familiar with the African proverb, if you want to go fast, go alone. If you want to go far, go together. But going together can be complicated. But we know that none of these kind of global, audacious, bold, innovative solutions are going to be able to be accomplished by one small organization alone. So maybe some of your experiences or thoughts that you've had as you've sought out the right partners and built that collaboration.
So, okay. So I'll give you a couple of different examples. In the frontline health case, we talked to a bunch of frontline health organizations and felt like triaging by frontline workers at home care might be a good problem. And then we talked to Gates Foundation. They organized a couple of workshops, inviting about 30 or 40 of their grantees, 2-day workshops. We learned a lot, and two things happened. One is that these organizations helped us realize that certain problems in maternal and child care, like infant mortality, actually was more urgent and doable. So we changed our mind. But moreover, in that process, they signed up to work with us. They said, if you do this, we'll actually be interested. On the other problem that we are working on in, say, tuberculosis eradication, in India, there is a tuberculosis care system managed by something called the Central TB Division. Anything you do, it's better you work with them, because the only real TB data available is theirs. They own it. So we have become an AI partner for the Central TB Division, but that also means that, being part of their discussions and planning and so on, but it's very valuable because it tells us, where we can actually make progress. In cotton farming, the project for which we are funded, there are actually an agriculture extension program that the state government has. So we reached out to them, and they introduced us to that system. But then we also found that there is a private sector, not-for-profit kind of an organization called Better Cotton Initiative that can actually be an early adopter of the solution and allow us to file it and try our stuff. So simultaneously partner with these organizations. And in each case, once they agree, they take you to the problem domain, take you to the people. Data collection becomes easier because they will do it for you, or they'll tell, give you the opening to do it, and then execution, of course. So.
Gavin?
Thank you. So partnerships can be hard for a slightly awkward introvert, I have learned. But I think that it's really interesting that in the business sector, I think partnerships are important. And I think for impact, they're just absolutely not negotiable. You absolutely have to do it. It has been stunning to see the impact that has happened in the climate movement in the last year.
Yeah.
As a lot of NGOs have started to say, why would we stand up separate technology stacks? Why don't we just all collaborate? And it's been amazing. 95% of companies worldwide have a sustainability team that uses the World Resources Institute protocol.
Yeah.
We just called them up and said, why don't you have all our data for free? We won't charge you, and you'll distribute it to every company in the world for free. You won't charge us. And then a similar deal with RMI, 90% of renewable energy developers worldwide. So the scale and speed of progress has just been stunning for what a little team of 10 people can accomplish because everyone's willing to work together in our field suddenly.
But to do that, you have to overcome what's known as database hugging syndrome, right? So every NGO, every company, every entity wants to hold on to their data, but it sounds like in this case you were willing to share.
And we've done it through a really interesting legal mechanism, which I think has potential for impact, which is that it's shared under what we call a mission source license. Okay. So we can get access to their IP and vice versa, as long as we have the same environmental mission. And I think that that is a really interesting innovation that will apply to other projects as well.
Well, this room contains a group, this is a very self-selected group of folks, I think technologists, developers, people who are really interested in thinking about applying AI to improving environment, social issues, poverty, women's rights. So to this room that's filled with, I think, aspiring and inspired pragmatic solutions folks, what would be your words of advice? Or maybe some lessons learned that you have for people who are thinking about how they can help contribute, how they can be part of applying technology to these huge global challenges?
I would certainly say collaborate, collaborate, collaborate for two reasons. One, you might be surprised at the low state of tech in the NGO sector if you're not already familiar. It's often just stunning what a really good developer can do in 4 hours of volunteering.
Yeah.
We've been really struck.
No.
And the other is it's really easy for well-meaning code to actually cause harm in sectors where the issues can be really complicated. It's so valuable to talk to subject matter experts first about what would really help.
That was very clear and concise.
Yeah, collaboration is a key. And for us, for example, if I did not have my friend who has this bioinformatic background to translate from a medical need to a technical solution, we would not be here. So I think it's very important to find a bridge between us, because as a medical person, I know what would be the need, but you are the one who can make it possible and who can bring the solution. And we are doing this every day in our project. So with the developer who is working on this application, Marco Pastucci, who is in the room, he speaks a language that I don't speak. And to be honest, most of the time, I don't understand. And it's the same for him. He does not understand when I speak about bacteria, infection, resistance. So we need to find a way from both sides to translate and to make the understanding of both sides easier. So people like bioinformatic people can be a way, but simplifying the medical or the development language can be a key element to ensure this collaboration.
Mm.
So I used to be a professor, so I can pontificate, which is, I think I'll break it into 3 parts. Why you should get into AI for social good, how you should do it, and what you should not do. See, I have an academic background, published enough, and I worked in the industry. I know what tech transfer takes and how it is to work in a very disciplined, structured environment. However, if you want to completely create and work on something that is, kind of create completely new, you need that space. So you go to the place where there is least amount of people working on. And actually building technology solutions for social domain is completely empty. There's not enough people like you out there doing it. And in fact, one of the things that we want to do is to attract more people to come and collaborate. You don't have to leave your job but you can find a way to contribute. But the opportunity to shape the direction is very big. And you don't have to follow what is the next greatest breakthrough in deep learning and do that. You can just solve some other problem that you define yourself. So to me, it's the most rewarding thing you can do. And if you do it right, you can begin to see it having tangible impact on people that you care about, lives around you. How to do it? You have to do it fundamentally with a collaborative mind, like other two were saying, which is like you can't think of the end-to-end problem. You don't know how to execute it. So you need to be very open and to listen to and take some risks on collaborating with people and change your course if you need to dynamically. It has to be very agile, but it also has to be something where you know what you can do, but work with other people. And what you should not do, and this is kind of important, it's not about advancing the state of AI or science, which is a fantastic thing to do. If your solution cannot be implemented and scaled, it's not worth anything. It can be a greatest piece of technology. So you have to look at programs and systems that can help you scale. Someday we hope we will change the system itself, but you're going to do that only when you learn how the system works. And you can't sort of start doing something and throw it out and see that it'll actually work.
So I'm going to open it up to questions in the audience in just a minute, so you can go to the mics here if you have questions for the panelists. But this has been incredibly inspiring. I think reading over these applications is one of the hardest things I've actually ever had to do in my 12 years at Google, and because there were so many amazing ideas and teams, but you all really stood out. Just wondering if you have any final words that you would like to say to this audience, these technologists.
I think it's much easier to jump into impact than I realized. My organization was only created because I showed up at a hackathon and some developers told me what was possible, and we built something on that day of.
See, good things can come out of hackathons.
One day.
We have our doubts.
So for me, it's in the title. It's the impact. I think it's very important to visualize the impact and how it's going to be used. And at least for medical question, I think it's a new era with the AI. So that the solution we should in advance think about once it is ready, how this is going to be used and what is going to be the impact. And for me, it's an advice, but also the biggest challenge when you think about the project.
I once had the privilege of having Jim Kajia, who's a very well-known graphics researcher pioneer, as my direct manager. And we would have these one-on-ones periodically, and at the end of it, he would say, okay, go change the world. And that's basically the best thing. It doesn't matter how you do it, where you do it. Once you get that as your goal, you'll have fun.